Hello students, our today discussion is about periodic classification of elements. Periodic classification of elements means how elements are classified. So what are the how many classifications we have from the periods of different times. So all this discussion as well as how elements are classified, what's the need of classification and what are the factors which influences to classify all these elements and what are the blocks in the modern periodic table and what are the family names of all these elements in the modern periodic table. So everything we'll discuss in this video. To start with, classification. Students, what is an element? Atoms of same type is called as an element. Yes or no? Atoms of same kind is called as an element. We have right now with including naturally found and artificially synthesized, there are 118 elements are there in the periodic table, right now in the modern periodic table. So why do we need to classify all these elements? And one more time, in the olden days we don't have these many elements are not discovered, okay. So whatever if the 30 elements or 50 elements or 60 elements they classify, they try to classify and they gave their own periodic table. So we'll discuss all these points. So first, what is the need of classification? Like what is the use of classification? Listen carefully. Students, the need of classification is, for example, you went to a library and for taking one chemistry book, okay, in the library there are different racks are there. In one rack there is one chemistry section, in another rack there is a physics section, maths as well as social, fictional, non-fictional, all these kind of different racks are there. You want a chemistry book, directly go to the which rack? Directly to the chemistry rack, yes or no? In the other case, if all the books were mixed up, then what you have to do, students? You have to check each and every rack or not. That means classification, that means classification anywhere helps us to go or to study in a easy format. Here also for elements, classifying the elements or classification of elements helps us to study about these chemicals in a easy format. That is the use of classification, that is the need of classification. So first, what are the early attempts of classification? First of all, in the early days, elements are classified based on their valencies. What is valency? The combining capacity of an element is called as valency. Like how many electrons an atom loses or gains or shares. That based on that factor, they try to classify. Early days, earlier year means like it's very so long. So at that time, there are only few elements were known. Later on, Lavoisier classified the elements as metals and non-metals. Like you already know the reason, you already know what are metals and what are non-metals. Yes, what are metals? Elements which have a capacity to lose electrons. What are non-metals? Which have capacity to gain electrons, having high electronegative character. But he didn't classify all the elements also, only few elements he classified under this section. Next some significant classification is done by the scientist Dauberinier, and his idea of classification is triads. This classification is called as Dauberinier's law of triads, which means, you know what he did? He took three elements and he placed these three elements like a group. Like look at the first group, lithium, sodium, potassium. Next, chlorine, bromine and iodine. Like this, few groups he classified like a triad. And you know what he said? The elements in one triad, they have similar physical and chemical properties. For example, lithium, sodium, potassium. He said these three elements have same property, and he gave a law which connects all these classification. The law is called as law of triads, which states the atomic mass of the middle element in a triad is the average of atomic masses of first and third element. For example, lithium, sodium, potassium. Lithium mass is 7 grams. Potassium mass is 39 grams. So what is the average of 7 and 39? 7 plus 39 by 2, which is 46 by 2, which is 23 grams, which is the mass of sodium. That's what his law is. But is this correct? Like how does this connect? Why first and third element? How does this connect all the elements? This classification, students, is invalid classification. Sir, why? But it happened for lithium, sodium triad, na? Means yes, it's a coincidence, that's it. But this law is not applicable for the remaining triads only. After all, you know, finding the atomic masses so precisely, whatever the Dauberinier gave, all are proven wrong, invalid. But that is accurately applied for lithium triad, which is a coincidence. So, and he didn't classify all the elements also. but this is an early attempt, so that's why we are discussing. Next, given by Newland. This classification is called as Newland's law of octaves. This classification starts from lithium, ends with calcium, students. This is also an interesting kind of classification, which is an early attempt of classifying the elements. Here also you can notice the elements which comes under Newland. Not all the elements were classified under this periodic table, which means whatever the law he gave, that is not applied for all the elements. And what is the law he gave? First of all, he classified the elements based on increasing order of atomic masses. So first lithium. Sir, first hydrogen means he didn't classify hydrogen. He didn't classify helium also. He didn't classify noble gases only. I'll tell you the reason. So he started from lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and again sodium is placed under lithium and it continued like this. Okay, here it is given like a single line, but sodium is placed again under lithium, magnesium under beryllium, aluminum under boron, and continued like this. So what he said? He said all the elements are arranged in such a way that every eighth element in the periodic table resembles the first element like musical notes. Just count 1, 2, 3, 4, 5, 6, 7, 8. What is the eighth element, students? Sodium. Sodium and lithium have same property. That is what the law of octaves. For the reason why he gave, sir, why only eighth element? If that is your doubt, he said because in the musical notes, what are the musical notes, students? Sa, re, ga, ma, pa, da, ni, sa. Sa and sa. The two sounds are first and eighth. Yes or no? He said, sir, how does this can be the reason? That is absolutely, irrelevant, students, but he want to give a reference, he gave this reference. And why he excluded hydrogen and noble gases? Why? Because if these elements were added in his periodic table, the law becomes invalid. So that's why he excluded, and whatever the classification he gave, this law is applicable for these set of elements only. He didn't classify the elements after calcium only. Don't think, sir, there might be no elements after calcium. No, gold is there from ancient times, sir, no, but he didn't classify all these elements. Next classification is also done by the scientist. Next classification is done by the scientist Lothermeyer, and he classified the elements based on atomic masses and atomic volumes by plotting the graph with atomic masses and atomic volume. So this classification is not also a significant classification. Not all the elements were also classified. So many errors are there in this classification also. Next main significant classification is done by the scientist Mendeleev. Mendeleev is a Russian chemist. Students, he is a Russian chemist. He classified the elements into 7 periods and 8 groups. He is the one scientist who classified the elements into groups and periods, and he classified all the elements based on increasing order of atomic masses. Increasing order of atomic masses. He gave a law for this classification. The law is called as Mendeleev's periodic law, which is very, very important. This periodic law is almost resembles modern periodic law. That's why this periodic law is very, very important. Let's see what does it state. The chemical and physical properties of the elements are the periodic functions of their atomic weights. What's the last state, students? The physical and chemical properties of the elements are the periodic functions of their atomic weights. Many students don't know the reason, don't know the meaning of this law. I'll give you the clarity. Listen carefully. The physical and chemical properties of the element. This clear, na? Are the periodic functions of their atomic weights. Here there is a doubt. Sir, what does it mean by the periodic functions? What does it mean? Mendeleev classified the elements based on atomic weights. Yes or no? And how does he classify, students? He classified the elements in the increasing order of atomic weights, but the elements with similar physical and chemical properties he placed in the same group. He placed in the same group. What are groups? What are periods? Vertical columns are called as groups. What are periods? Horizontal rows are called as periods. Got the clarity? Vertical columns are groups, horizontal rows are called as periods. So how Mendeleev classified the elements? He classified the elements in such a way, the elements with similar physical and chemical properties are placed in the same group. But every time the element is getting placed in the different period. Yes or no? Yes or no, students? Same group, but every time does it place in the same position, same block only? No. Next. That means different periods or not? Elements are classified under different periods or not? So that is what the periodic functions meaning. That is the meaning of periodic functions, students. Ultimately, all these elements are classified on what basis? on the increasing order of atomic weights, right? So that is Mendeleev's periodic classification, students. There are many points are there under Mendeleev's periodic classification, which is he is the first scientist who classified all the known elements. So he's the first one, as well as he predicted some unknown elements also, like Aka aluminum, Aka silicon, Aka boron, all these elements. And he's the one who corrected the atomic weights also, and he gave the perfect positions for the elements. So many important classification which is done by Mendeleev. Next, there are some drawbacks in the Mendeleev's periodic table. Those drawbacks were rectified by the modern periodic table, which is classified by the scientist Moseley. Moseley classified the elements under this modern periodic table. So what is the best point? So what is the best point to classify all these elements? You know, the best point, the best thing to classify all the elements is not atomic weights but atomic numbers. What is atomic number, students? Atomic number means number of protons in an atom or electrons in a neutral atom is called as atomic number. Yes or no? Can two different elements, can they have same mass? Yes, it is possible. Yes or no? Isobars. Can two different elements have same atomic number? Is it possible? No. Different element means different atomic number. Same atomic number means same element only. So what's the best thing to classify the elements? Atomic numbers are the best, thing to classify the elements. So Moseley calculated the atomic numbers and he classified the elements based on atomic numbers. So whatever the drawbacks from Mendeleev's classifications were rectified under this modern periodic table. So students, periodicity, we can see this periodicity even in the Mendeleev's periodic table also. What is the periodicity meaning? Is a reoccurrence of similar physical and chemical properties of the elements when arranged in a particular order. Same, I said in a periodic function, same, that is the periodicity. Periodicity means elements with similar properties are placed in the same group at every time in a different period. Yes or no? That is periodicity. So what is the reason for the periodicity? What is the cause of periodicity? It is due to the repetition of similar outer shell electronic configuration at certain regular intervals. I will explain the meaning, listen carefully. Modern periodic table is not just classified according to atomic number, students. Modern periodic table is also classified according to the electronic configurations also. This is a very important point. Modern periodic table is not just classified according to the atomic numbers but also according to the electronic configuration. Let's see how. So what is the first group element, students? What are the first group elements? What is the configuration? Let's say hydrogen. What is its valency shell configuration? 1s1. Next lithium 2s1. Next sodium 3s1. Potassium 4s1. 5s1. 6s1. 7s1. Yes or no? Second group elements. What is the configuration? Beryllium 2s2. Magnesium 3s2. Calcium 4s2. 5s2. 6s2. 7s2. What is the common thing in all these elements in one group? What is the common thing? Their valency shell electronic configuration is common. That's why they have similar chemical properties. That means for having similar chemical properties, what is the main factor? Configuration is a factor. Which configuration? Valency shell configuration. Sir, why only valency shell configuration? Why? Because only valence electrons involved in the bonding. Got the clarity? Got understood why they show similar properties? That is explained by this modern periodic table. All the elements in one group have same property because they have similar valency shell configuration. Let's take any group. Let's take 17th group elements: fluorine, chlorine, bromine, iodine, acetylene. Fluorine, what is the configuration? 2s to 2p5. Chlorine, 3s to 3p5, 4s to 4p5, 5s to 5p5, 6s to 6p5. Yes or no? Of course, radioactive elements are there down, no need to discuss. So all these elements have s2p5, s2p5 configurations or not? That means their reactivity is same or not? That is the reason for periodicity, having similar outer shell electronic configuration. Got the clarity? One main point here to remember: modern periodic table is not just classified according to atomic numbers but also according to the electronic configurations. Molecular diagram, yes or no? The order of filling electrons. Based on that order, modern periodic table is classified. So look at the main points under this periodic table. In the long form of the periodic table, modern periodic table is also called as long form of the periodic table. Mendeleev's periodic table is called as short form. Why? Because it is like an extension to the Mendeleev. So there are 18 columns. Columns are called as groups. I said no, groups. These are groups. And horizontal rows are called as periods. So in the modern periodic table, all the elements are classified into 18 groups and 7 periods. Students, how many groups? 18 groups and 7 periods. And Answer, the elements in the same period or same group where they show similar property. Same period or same group? Same group, remember. Why? Because they have similar valence shell configuration, right? So next, elements present in the group 1 and 2 on the left side and group 13 to 17 on the right side of the periodic table are called as normal elements or representative element. That means simply S block elements and P block elements except noble gases, they are called as representative elements, means main elements or normal elements. Generally, for example, nitrogen gas, oxygen gas, this oxide, that oxide, all are found in these blocks only. That's why they are called as representative or normal elements. Next, in the periods, elements are arranged in the increasing order of their atomic numbers, right? Students, first period, first, what are the elements? Hydrogen, next helium. Why? Hydrogen atomic number is 1, helium atomic number is 2. Got the clarity? Next, lithium 3, beryllium 4, 5, 6, 7, 8, like understood? Sir, why again they placed under? Why? Because they show similar property. That's why again sodium is placed under lithium. Got the clarity? Because why similar property also you already know. Similar valence shell configuration. Next, some other points, students. Generally, every period starts with alkali metals and ends with noble gases. About these family names, in a different slide we'll discuss all these names and the meanings. So every period starts with which elements, friends? First group elements, yes sir, no. And every element ends with last group elements. What is last group? 18th group. First group to 18th group. First group elements are called as alkali metals and the last group elements, 18th group elements, are called as noble gases. The first period is the shortest period of all, contains only 2 elements, hydrogen and helium. Next, the second and third periods are called as short periods and contains 8 elements. Fourth, fifth contains long periods, 18 elements. Sixth and seventh are these are the long periods which contains 32 elements each. First period contains how many? 2 elements. Second, third contains how many? 8. Fourth, fifth contains how many? 18. Sixth, seventh contains how many? 32. Why? There is a reason, listen carefully. This classification, but not only by atomic numbers, this classification is also done based on electronic configuration. Yes or no, students? I said clearly. Now listen. According to the electronic configuration, which is the first orbital we'll fill first? 1s configurations. Right? 1s, S maximum can accommodate how many electrons? 2 electrons. So 1s1, 1s2. Got the clarity? So how many elements can fit under this 1s configuration? 2 elements. That's why in the first period, how many elements are there? Only 2 elements. After filling 1s2, electrons enter into, students, electrons enter into the second shell. In the modern periodic table, elements are entering into the second shell. That means every period in the modern periodic table indicates valency shell. Yes or no? This point. Yes or no? First period, which elements we have? Hydrogen, helium. What's the configuration of hydrogen? 1s1. What's the configuration of helium? 1s2. First shell is completed or not? First period is completed in the modern periodic table. Next, elements enter into the second period. Second period starts with lithium. What's the configuration? 2s1. Next, beryllium, 2s2. Next, boron, 2s2p1, 2s2p2, 2s2p3, 2s2p4, 2s2p5. Ends with neon. What's the configuration? 2s2, 2p6. Second shell is completed or not? Second period also completed in the modern periodic table. So how many elements they can fit? How many elements, students? 2s. S can accommodate 2 electrons, P can accommodate 6 electrons. 2 plus 6, how many? 8 electrons. Which means 8 elements are there possible. Understood, students? First period 2 elements, second period 8 elements. After 2p, electrons enter into 3s and 3p. S again 2 elements, P again 6 elements. Yes or no? From 3p1 to 3p6. Total how many elements are there? 8 elements. Here one doubt. Sir, 3D is there now. Why 3D is not? According to the configurations and according to the energies, after filling 3p, what is the next orbital to fill? The next orbital is 4s. Yes, sir, after 3p, elements enter into the 4s. 4s means in the modern periodic table, element starts from which period? Fourth period. Every period indicates a valence shell. 4s. After 4s, now we have 3D elements which are placed between S block and P block. How many elements are there? 3D? 10 elements are there, students. 3D how many? 3D1, 3D2, 3D3, 3D4, 3D5, 6, 7, 8, 9, 10. 3D is placed after 4s. Why? Because in the writing the configuration 3D comes after 4s. That's what I said. This classification is ultimate classification, not just classified according to the atomic numbers, but also classified according to the electronic configuration. So systematically, structurally, all the elements were classified. So 4s, 3D, 4p. Total how many elements are there? 4s, maximum 2 electrons. 3D 10 electrons, 4p 6 electrons, 2 plus 10 plus 6, how many? 18. 18, yes or no? That's why in the fourth period, how many elements are there? 18. Fifth period, 5s, 4d, 5p. How many elements? 5s, 2 electrons, 4d, 10 electrons, 5p, 6 electrons, 2 plus 10 plus 6. How many? 18. Sixth period, 6s, after 6s, it's not 5d. 4f elements are there. F can accommodate how many? 14 electrons. So how many elements are possible? 14 elements are possible. So 6s, 4f, next 5d, 6p. These are the configuration elements present in the sixth period. That means 2 plus 14 plus 10 plus 6. Total how many count? 32 elements are there. Next seventh period, 7s, 5f, 6d, 7p. 2 plus 14, 16. 16 plus 10, 26. And 16 plus 10, 26. 26 plus 6, how much? 32. Yes or no? S electrons, F electrons, D electrons and P electrons. Every configuration with one element. Yes or no? Total 32 elements are there in the seventh period. So why these F block elements are placed at the bottom, that also we discussed. Got the clarity, students? This is the main point here. Main point, and all the reasons also we discussed, students. Like first period 2 elements, second period, third period 8 elements each, fourth, fifth, sixth 18, and sixth and seventh 32 each. That's it, students. Periodic table is very important chapter, students. Periodic classification of elements. We discussed all the early classifications, Mendeleev periodic table, modern periodic table, and how these elements are classified into blocks, and what are the importance of each and every block, and the family names, everything. All the main points are there. And modern periodic table is the ultimate classification, students. So that's all for today in this video, and the remaining concepts we'll discuss in the next video. Thank you, students.